Hi. Recently I was in need for some high voltage capacitors and I was amazed on how expensive they are compared to their storage capacity. So I've decided to build one using some household items. For this project we will need some nylon foil for the dielectric, aluminum tape, a pair of high voltage wires, and an arc welder electrode. For the last part, any thin, rigid stick will work, preferably made from a non-conductive material, but this is what I had around. I spread the sheet of foil and marked the length of 1.5 meters, as this would create a decent capacity for our high voltage capacitor. After marking the line, I bent the nylon and doubled its length to 3 meters, then cut it. Next step is to spread the aluminum sheet over the plastic foil. This will be the first armature of the capacitor. It is important to be center placed in order to avoid high voltage contournations. I used the aluminum tape to stick the high voltage wires to the aluminum foil. Then I cut 2 sheets of aluminum tape with the same width as the aluminum foil. It is very important to maximize the surface area by spreading the wire conductors apart. Then I press the aluminum duct tape close to the end of the aluminum foil. Here I'm using a weak paper glue to prevent the aluminum foil from sliding on nylon surface area. Also, there is no need to glue the entire surface area of the foil, as this will ruin the rolling process later. You don't want to use a strong glue at this stage, as it will prevent you on doing later adjustments. The first armature is done. Now it's time to cover it with the rest of the nylon. This layer will serve as dielectric for the capacitor. Another layer of aluminum foil is placed parallel with the previous layer. Then I repeat the same procedure as before. After I glue this end in place and I attach the high voltage wire, our plain capacitor is almost ready. At this step, it is important to use a very strong glue for the electrode. I use Mitrapel, which is the same as super glue, but it has an activation agent which makes it harden in just a few seconds. And in case you wonder why I've decided to glue an electrode inside the capacitor, this will serve as a gripping support for pliers in order to ease the rolling process of the capacitor. Now it's time to roll the capacitor. At this point, the main challenge is to align the foils to be perfectly parallel to each other until the end. Now our capacitor may not look pretty and has a big hole in its center, but here is where the electrode comes in handy. Using a set of pliers, I take a grip on the electrode and gently twist it. The interior torque will tighten the capacitor layer by layer until it becomes solid to finger pressing. Do not force the tightening process as you don't want to rip the interior apart. I use rubber bands to secure the layers in place and avoid unraveling. I twist another few turns and our capacitor is now ready to be tested. But before we do a capacitor test, let us calculate what values we should expect, so we will know if anything went wrong. So the armatures of our capacitor are 1.5 meters long and 29 centimeters wide. This gives us a total area of 0.435 square meters. Using the plain capacitor formula and knowing the dielectric constant of nylon, which according to this site is set between 3.2 and 5 times the dielectric constant of empty space, this gives us a wide range where our capacity might be at. Although I couldn't precisely measure the thickness of our nylon foil dielectric, I approximated to 0.15 millimeters. So let's average this constant at 4 times the dielectric of vacuum space. The result is inserted into our formula, which gives us a total capacity of approximately 100 nanofarads. Of course, this is the theoretical case, which we can never touch in homemade conditions. This is why in practice we should expect a capacity slightly lower than what we have calculated. So I would expect anything between 85 to 90% of our calculated value. If we measure way less, this means something went wrong with our armatures during the rolling process. So this cheap eBay SR meter reads a value of almost 86 nanofarads with a 0.3% V-loss, which sits between our calculated range. Using the dielectric strength of nylon, which is 400 volts per milli-inch or approximately 16,000 volts per millimeter, I can calculate the maximum operating voltage. This means that for our dielectric thickness, the capacitor can withstand a maximum of 2400 volts. But operating it in the safe parameters is boring. I want to test it at its limits. So for this I will use this flyback transformer, which I have modified to drive it in push-pull mode with my ZVS Mazzilli driver. Because of high voltage built-in diode, this transformer gives us a DC voltage output. After hooking it up, I have noticed that I don't have a way of precisely measuring voltages that high. Perhaps I will use this topic for another video. As for now, I will have to approximate it using the breakdown voltage of air, which is roughly 3000 volts per millimeter. As it happens, the maximum breakdown distance of air for this setup is about 10 mm, which gives us roughly 30,000 volts. Now let's see if our capacitor can hold this charge. Unfortunately, my low FPS camera cannot capture such short pulses of light. In this test, I rely on the very thick wire insulation and the DC nature of current, and I hold the high voltage wires by hand, hoping this will give a better result. Do not ever try this on yourself. I wouldn't dare to do it if it were AC voltage, as current will conduct through parasitic capacity of the insulation. Well, it had to happen eventually. On the last test, the dielectric was pierced by the high voltage. However, it lasted quite long given the fact that in this test I used over 12 times the maximum voltage rating for this type of dielectric. Anyway, I decided to test its capacity again to see if it lost any. Well, that's a surprise. The capacity has actually risen to almost 89 nanofarads, and so the V-loss. I was expecting for the capacity to rise after testing it, because the opposite charges attract each other, so the aluminum armature will smooth out more and get closer to each other. Depending on what feedbacks this video gets, I might or I might not make a continuation on fixing this capacitor, and maybe improving its high voltage resilience. Until next video, let me know in the comments what do you think I should do with this much nylon foil. Thank you so much for watching. If you like this project, please subscribe and share this video, and stay tuned for the next one. Bye!